Hello everyone. Today we will be seeing one of the problem from Geeks for Geeks, which says row with a minimum number of ones. So it gives a question which says given a 2D binary matrix with one base indexed of dimensions n cross m, determine the row that contains a minimum number of ones. So note the matrix contains only ones and zeros and etc. etc. So let's see one by one examples. Within the first example, we see the first row having 4 ones. Next, 2 ones, 2 ones and 4 ones. So obviously 2 ones is the minimum number of ones, but to choose which one of the row. So we'll go ahead and we'll choose row number 2 starting from 1. Why? Because so it is said that row which contains minimum number of 1, and whensoever 2 or more rows contains minimum 1, the lowest of indexes needs to be returned, and in this case row 1, the first row itself, as this is one based indexing. So this is very straightforward questions, and this is very quite basic level, and it has been asked within Amazon. So I believe the most common purpose of this being asked is first of all to judge the hands-on experience. Second is to get into the basic level. So if the candidate is not well prepared, so we provide a question, but she is still unable to solve the questions, we drop a one level less and we see such kind of questions. And third is something like how the way you handle constraints. Still curious about what it means, so we'll get ahead into code and then we'll come to know how hands-on and how constraints are being checked within an interview. Stay tuned. So once we are well equipped with the problem statement, let's go ahead to code. Now we have been provided with an array A, n and m, size of an array, dimensions for it. So what we would do is we would just simply go ahead, iterate one by one rows each, and once when we see the minimum number, we go ahead and update minimum index. So I'll say minimum index initially is 1, and then if and along with it I'll keep minimum count as well, which is integer dot max value. You can take the column size as well, but both things are one and the same. So I'll go ahead and iterate one by one rows each. So a row within A, and let's go ahead with a good naming here. I'll say matrix, and I'll say matrix over here as well, and for int element within row, I'm going ahead and checking if element is equal to 0. I'll continue. If element is equal to 1, I will increase the 1 count. Row 1 count I will say, and I will increase it. So you might be wondering what row 1 count is. It is nothing but the count of ones within this row. Initially it is 0, and as soon as we see one by one elements, we go ahead and update it. But if it is not, then else we throw, let me indent it properly, else throw new illegal argument exception. So this is what I'm saying. And I'll just go ahead and say, if I can do it well, invalid matrix value. Well, so this is what I'm saying. You need to handle the constraints very well. You just don't need to rely upon whether it's 0 or whether it's 1. It can happen that within the matrix you are having apart from 1 and 0 rest of elements. In that case you need to handle that cases as well. It might happen that matrix itself is null, so you need to go ahead and check if matrix is equal to null, and in this case as well we'll go ahead and throw a new illegal argument exception, but this time saying null matrix. Well, and in such cases, once we are done with row 1 count, we'll go ahead and see if row 1 count is less than minimum count. Then we go ahead update minimum count, which is equal to row 1 count, and we'll go ahead and initialize min index is equal to current row index, whereas current row index is nothing but G1 initially because it's 1 based indexing, and once we are done we go ahead and update current row index with the next one. And ultimately once we get it, once we are out of this loop, we are sure to get a minimum index with minimum count, but we are returning only minimum index, so we go ahead and do minimum index. So yeah, it's done. So we can compile with sample test cases. It works well with sample test cases. Let's check for the rest of the test cases as well. Yeah, so it passed the rest of the test cases as well. So coming back to this question, the main and sole purpose of this question is mostly checking how the candidate handles most of the test cases, how the pattern does he follow camel cases, or if you're going ahead with a C++, Python, any of the snake cases or any of the convention which you follows or not. Make sure to name your variables well. Make sure to follow conventions. Be consistent with your braces. So here I have used K and R indentation style. So if you're using almond style or any other style, be consistent with it. And again, it's all about handling edge cases, so just do not ignore that. Again, the time complexity and space complexity of it is O of n into m, as we are iterating each and every element, and elements are n cross m, and we are not using any other space, so expected space complexity is O of 1. So this was all about it. If you wanted to know how can you get minimum number of ones in a sorted way, and that too with much lesser time complexity than O of n cross m, then click the video on your right, and I'll see you in the next one.
Ooh, you wanna come and get me, kick me down.